Okay, let's do this banner. Obviously, I'm going to pull hard for Tony Stark. I'm trying to make Captain America a flying monkey today. Um, there was one part that I wanted to specify for Captain America being my flying monkey around here. If you know some basic codings and how to do the ball, right? Very cool, but these pictures actually change around. Look at that geometry change around. Those are very important photoelectric effects. It's doing something from a central node. This set over here. Do you need five? I don't know. Maybe three would be a better answer, seeing it's its maximum, anyways, right? We can get, once you do the top part of it and Pi Games print that, that would be the show function. Where's show? Or, in a way, the rudimentary language is weird like that because in the first set, if we do this first order, if there's only 0 and 1 and -1 to consider, well, then that's what I have to do with those three dots inside of that order. And I have to do that in function because, as you'll see, he's taking stuff away, he's repeating it, and he does it specifically 3 times. Why? Why is that important over here to what there's? Well, there's some general base function that's got the is to it with the caveat of that a in a position that's being notated. We don't really know what now is, but that's a function that this computer knows before I say a equals or g equals 1. Then it's going to change y inside of a system like that depending on the derivative, again, because it can get, that has those caveats at places where we can make it more abundant, say that is is a function like that because is is a function like that, capital A, lowercase a, the equal symbol. When you're starting to break them down, like, oh, so that's where I've seen a closed surface integral before. Yeah, because we had to do it with 6 guys. And or that could have been a closed table integral in the way we explained, the axis of how you were attacking that. In a pie chart, that would be a closed surface for a radial in any one of those directions, kind of part of each other, but you can kind of do the electricity dance because they're all one step away from a singularity on the pipes, jumping around, crossing signals. Coming down into here for what the wave function is, we'll take those data once we've compounded enough of them to build some kind of array about, pass, fail, as long as they got numbers in there, it's a thing. As long as that number is in this function here, again, the total nature of this has these fractal pieces, so it's a derivative, but essentially 1, 2, 3, right? The first part has these 2 parts, which makes it heavier but lighter at the same time. Gamma and long wave radio signal, you're reading the equation the matter, antimatter, Fermilab matter, this matter. Okay, they're basically, when we do the sheets to do an email later, I just need these columns and these columns. I'm glad you're in that staff department keeping track of all those additional wave functions to see them cross over, see special signals, and again, that 1, 2, 3, or 4 set here, or again, whatever, high and low. These are the biggest drivers. Most of that cores around this other stuff, NASDAQ and Dow, all right, S&P, Russell. Doge, ETH, or well, bit, ETH, and Doge kind of thing. But that is why. Okay.